Ever wondered how car suspensions keep your ride smooth? Or why your mattress bounces back after you get up? The answer lies in a simple, yet powerful principle called Hooke's law. By understanding Hooke's law, you can grasp the fundamental concept behind how elastic materials behave under force. Hooke's law states that the force needed to stretch or compress a spring is directly proportional to the distance you stretch or compress it. This is expressed as F equals K times X, where F represents the force applied, K is the spring constant indicating the stiffness of the spring, and X is the displacement or how far the spring is stretched or compressed. Let's solve a quick problem. Suppose your car's suspension system has a spring with a spring constant of 200 newtons per meter, and it compresses by 0.05 meters when you hit a bump. What force is the spring exerting to absorb the shock? The spring constant K represents the stiffness of the spring. In this example, the spring has a constant of 200 newtons per meter, meaning it requires 200 newtons of force to compress the spring by 1 meter. The displacement X is the distance by which the spring is compressed. Here, the spring compresses by 0.05 meters, or 5 centimeters, when the car hits a bump. Using Hooke's law, we calculate the force exerted by the spring. Substituting the given values. F equals 200 newtons per meter times 0.05 meter. Solving this gives us 10 newton. This 10 newtons of force is what the spring exerts to push back against the compression caused by the bump. In practical terms, this force helps to absorb the shock and maintain the car's smooth ride by preventing the car from jolting too much when it hits the bump. Hooke's law is foundational in understanding how things work, from car suspensions to everyday objects. Mastering it brings you closer to mastering physics. If you found this helpful, like, subscribe, and share it with others.